Hello guys, today we're gonna have a look on my Formula 1 2026 car and I'm gonna show you how it looks in a CATIA V5, and also we're gonna have a look in CFD results and how the flow behaves around certain areas and where are the key areas for improvement, especially on this one car. So let's start with the front wing. I designed very basic front wing. I tried multiple versions and now I wanna get serious with the development, so I started very basic. This is basically a copy of the FIA front wing. Also the nose is pretty much a copy with the center chassis and back chassis designed my own. I designed my own front wheel hubs and also rear wheel hubs. As you can see, there are some fins, some deflectors around this area, around the brake inlets, outlets, and also the bottom rear deflector, which is supposed to manage inner tire squirt and outwash it out uh, so it doesn't hit the floor later on. Alright, so moving further back, I designed slightly downwashing side pods. They're basic, basically the idea is to keep the engine cooling losses going through the louvers out here, and they are traveling along the side pod and the engine cover through this part, and they are exiting right beneath the rear wing and above the diffuser, so they don't hit any important parts at the back. Then we have quite simple but yet effective G-line, which has some curvature to it. So basically with the undercut, we are outwashing the tire wake outside and we are pulling the clean flow right around the G line here, right here, and to the diffuser, to the upper part of the diffuser. So we have better extraction at the back. But with the upper part, it's pretty simple. I try to close the cooling exit as much as I could, so I'm not gonna have too much drag from it. But there are two areas where I can improve here. Maybe I can add the shoulders at all Mercedes had in 2023, so the cockpit losses stay inside and they are traveling further downstream and they don't hit anything. Or maybe I can use something like Red Bull is using. So basically the airbox will be getting wider and wider as it travels to the back, and the cockpit losses will be dragged down through the slope, which would be sitting around here. I'm gonna have a look at these ideas, try them, and what will look to be the best version for me, I'm gonna implement it, and hopefully it will work better than it is now, because now I'm not meeting the cooling requirements that I wanna meet. I'm trying to meet the requirements from the Mantium Flow Challenge, so shout out to them. That's pretty good competition where you can register and design your own car. There are some rule sets. It's basically something similar to Formula 1 cars for this season, but the rules are pretty simpler. You don't have any curvature rules. You just need to design geometry and fit it in the regulation boxes. That's all. So shout out to those guys. And yeah, let's continue. So as you can see, I have rear brake deflectors as well. And also this floor winglet, or how's it called? Those are all my versions. I don't have access to the FIA CAT portal, so I had to design them by my own ideas and by my own knowing. So hopefully it works pretty good. It looks similar to what it should be. So yeah, that's pretty much it. Then moving to the floor. floor is again flat this season. Last years we had venturi tunnels, now we have flat floor. We have floor leading edge devices, which are basically vortex generators that are helping to seal the floor. The vortex is shed in this direction, so it's clockwise, looking from the front, and is traveling along the edge all the way to the back. Then we have floor corner with some slots, which are which should be basically managing the rear tire squirt and rear tire wake so it doesn't enter the diffuser. I'm not very successful at that, but still I have pretty good numbers from this car. So that's about CAT. Let's move to the other program and I'm gonna show you how I simulate it. So you can see the car is the same. Basically, I import everything into the Mantium Flow, which is CFD software based on OpenFOAM. I import my geometry into folders, then I open it here. I set RC, then I can go to settings, change something. Basically, I'm changing base cell size so it runs faster, and also I'm setting the limit for 2000 iterations. I am also playing with right height adjustment and rake. So as you can see, this car is running something about 1 degree rake, and also the ride height is adjusted up to it. So the clearance at the floor beep is around 22 millimeters, pretty much. So once you set everything, you build a case and then you run the case. It runs for 10, 12 hours depending on your setup. As soon as the simulation is finished, the program closed, you open the folder again, you hit the post-process case, and you are going to have something like this. This is the post-processing folder. This is fine. You can find this file in the post-processing folder. You can see the plots here, force development plot, also overall force coefficients, how they were evolving through the iteration, so you can see that it was stabilized at the back, so the results should be okay. You can see the numbers here. You have reference area, then you have drag coefficient, lift coefficients, ratio of those two, front lift coefficients, rear lift, and center of pressure. So I have center of pressure approximately 2 meters behind front axle center line. Also, below the numbers, you have some geometry pictures, and then there are some CFD pictures as well. So you can use those for your analysis. It's pretty simple, and for basic development of someone like me who is not aerodynamicist, this was enough, but I wanted to step up. I wanted to improve my game, improve the stuff that I'm learning. So then I started using ParaView. So as you can see, I imported the geometry already here. This is slightly different car because the one that I showed you in CATIA is still in development, but the side pods are slightly changed and there are no cooling louvers here, but basically the rest of the car is same. Front wing, rear wing, and floor are all the same as from what you saw in the CATIA. So now you can see the pressure plots around the car. Let's turn it from this point so you can see the floor. The front part of the floor is working pretty good also. The front wing, the first two elements are working good. Then we have some separation at the third one. So maybe I can make the cord shorter or lower the angle of attack. And also you can clearly see the function of the front wing strake here. Basically, it's splitting the front wing into two areas. You can see that the middle part is working more hardly than the outer part, and also I'm going to show you later what the vortex it sheds. So In a diffuser, I try to move the kick line as far to the front as I could. Also, we have some regeneration area here, which is green, and then we have the second kick to get the air out of the diffuser. You can see that the floor wings are also pretty blue, so they are used to their potential, or at least I believe they are used. Also, we have some separation at the back, so maybe this can be lowered if FI allows it. I don't know. I didn't see the rules regarding this part and how can you modify it. So yeah, moving up, we have rear wing. I use pretty long second element, and also you can see that there is separation on the third one. So third one is mostly causing the drag and not really much downforce. So ideally, I would adjust the chord length of the second and third element so we don't have this green spot right around here. To the side pods, I try to use the undercut to push the front wheel wake outboard. We're gonna see the Vorticity in a bit, and you'll see how I managed to do that, if I succeeded or not. So yeah, then I use the upper surface to direct the clean flow right around this area and above the diffuser. I didn't use full water slice because the engine cover regulation box is slightly shorter than from what it was last season. So the slope would be too harsh and I was scared I would get some separation or that it would cause too much lift because basically when you're designing water slide side pods you are putting a lift surface or suction surface at the top. So it's always generates lift. So I end up with something like this. It's inwashing and slightly downwashing as well. As you can see, I'm gonna put it on the side. So the curvature is convex at the start and then it changes to a little bit concave shape so it doesn't generate a lot of lift, but rather the pressure. And also there is lower pressure under the side pod, which is good. So we are not getting too high lift numbers from the engine cover itself. So this is the car with pressure plot. I'm gonna change it to these streamlines on the surface and other side. Now you can see how the flow travels, and also we can see some separations. There is big separation under the dive pipe already, so maybe even making the radius bigger would help this area, changing the angle of attack and stuff like that. Because this separation is traveling all the way down the end plate. Also, there would be needed some slight adjustment to the front part because we have some separation here already as well. But looking from the bottom, the front wing looks really okay. The flow stays attached to the very back. There is only very small portion of the green area. This can be also due to the size of the mesh I'm using, and maybe it's just the CFD limit. It would be better with a higher number of cells in a CFD, but I think it's still pretty decent. It's pretty decent to see how the car behaves. Right, so now to the interesting part. You can see that the flow is traveling inboard here. And basically, we have high pressure right before the tire. So after the tire, there needs to be suction, lower pressure and suction. So basically, if we are inwashing right before the tire, it changes to the outwash after the tire. And also the streamlines are saying the same thing. you can see that the flow is inwashing here. It's going basically along the center line here, and then it starts outwashing around the rear control arms and around the foot plate or floor foot. It's already pretty outwashing, and it's going mainly through this channel where is junction point between the floor and floor foot. So we have nice outwash here, and that cleans the flow that is going to the floor body and under the floor body and to the diffuser. So you see, this is not a separation. These are vortices that are traveling along the edge. Later on, they are shared by the floor leading edge devices. And also we have one vortex shared by the floor T-tray or floor beep. So then we can see the suction peak at the diffuser throat and also the second kick where the flow is faster again. Now I'm gonna change the wheel to the vorticity. Can turn this off. So as I was saying, the front wing strake is diverging the front wing into two parts, in the middle part and the outer part. Also, we are allowed to have foot plate that is coming inside, inboard of the end plate. And that's very useful because you can shed powerful vortex that may merge with the inboard tire squirt, which has direction that is, wait, I'm gonna change it like this. Okay, so the flow is sucked by the front wing and the vortex is forming in the direction of the inboard tire squirt, which is anti-clockwise on this side, and it's downforce producing vortex. So you're gonna put some strength in it. Also, you can see, now we can move it back to the bottom wheel. Okay. You can see how it inwashes here, and then it goes around the tire, and right after the tire, it outwashes. This green one, this is very slow vortex, this is dirty air, and it's mainly because of this deflector. It's not properly aligned, so I'm gonna have to do some adjustment to that, and basically I need to get rid of this slow vortex that is forming up here. Then you can see pretty strong vortices, which are basically the downforce generators for the floor. We have the beep vortex around here, and then we have vortices from the floor leading edge devices, which merge along the floor edge, and they are traveling along the floor edge, basically sealing the floor. And then in the diffuser, we have some vortices that are forming on the side of the floor corner, and also we have the tire squirt that is leaking through to the diffuser and it's weakening. So ideally, we would want to get rid of this one vortex or mainly put it on a side and not let it go to the middle part of the diffuser. So on the upper side, I have some separation around the airbox area and also around the side pods. So ideally, I would want to get rid of those. But you can see how the outer foot plate vortex forms. So all these devices are powered by rotation of the front wing and suction of the rotation of the front tire and suction of the front wing. So they are all going to be anti-clockwise on this side. This is basically dive plane vortex, which I'm not sure what I can manage with it. It sits in the position of the mid wake, so I can maybe split the upper wake and lower wake and manage them separately later on. I don't know yet. So moving further down, you can see this looks really nasty, but it's actually not. You want to have a high pressure area here and basically upwash this or let it go outside and clean the flow going to the floor from the inboard side of the front wheels. And I'm pretty good with doing it. The blue slow air is basically stopped here and it's upwashing through the slots. But we have also some vortex forming here. This is mainly because it merges with the upper tire wake, which I'm gonna show you later. And it travels all the way to the rear tire. This simulation isn't very detailed, so it stops here, but in real life it travels all the way to the rear tire. Basically, we can use it and burst this vortex onto the rear tire to lower rear tire drag. That can be one use of that. Or maybe we can use side pods to divert it to some area where we can use it later on. Alright, so this is from the 3D. Now let's go to the last part of the video, which is cut in X. I'm gonna show you these flow structures in X. So we are starting with the front wing, and you can see the foot plate vortices are forming already. Also, we have strake vortex and outer foot plate. There is some small vortex forming here around the dive plane, and those in the middle are the vortices formed by the front wing pylons. Also, we can see the wake of the front wing forming. Going further down, you can see how these vortices are strengthened by the rotation of the tire. So the rotation is this way, so this face is going down and is pushing the air in this direction, in the same direction as we formed the front wing vortices. So this outwashing vortex is gaining strength from the tire. Now it's pretty strong. We can see the lower and the upper tire wake, and they are split right here. As I said, the middle vortex is basically splitting these two. Going further down, you can see how the floor foot is sucking that vortex outboard and putting it in the desired area. So basically we have this outwashing vortex, and we are sucking it under the foot and putting it on the edge of the floor. It sits right here, and then we are forming vortex from the floor leading edge devices. We have also the vortex from the front bib, and this is the vortex from the upper tire wake. We have some separation on the side pod, as I said already, so this is not ideal, but let's move it a little bit back. Alright, so as you can see, the floor is sealed pretty in pretty good way. I have one big vortex sitting here and three other that are on the outside. These vortices are complementing each other, so they are not destroying each other. They are traveling together to the back of the car, and we have this portion of the floor which is sealed from the inboard and from the outboard as well, and there is pretty good air inside of it. There is good clean air with high energy that can travel all the way to the back to the diffuser and can be used for expansion, as you can see it here. So let's go a little bit back here. Okay, now you can see the clean flow made it all the way to the diffuser. Then it's expanding. We have diffuser vortices forming in the corner. Then we have again the strake, which is separating this vortex, so we have clean expansion in the middle, and we have diffuser vortices housed in these corners. This is basically the wake of the car, and you can see there are some flow structures which are dirty from the rear tires. Well, basically we cannot get rid of it since we have open wheel Formula 1 cars. Also, we can see the end plate vortices, and all this wake is upwashing with the front wing. So this is approximately some 5 meters behind the car. Let me put it at the back. So this is 5 meters behind the car, And as you can see, the air isn't that disrupted, or at least the low CPT air is sitting quite high. So the next car should be in a pretty good flow. Maybe the front wing can be hurt a little bit, but other than that, it should be all right. So hopefully we'll see better racing this season, and hopefully we'll see some interesting ideas on the car as well. So thank you for watching my video. I hope you liked it. If you liked it, please leave a like, comment, anything. I'm not aerodynamicist, but I did my best to explain to you everything I understand from this simulation, from these regulations, and I did my best to give you some insight even before the official testing starts. So you will find a link to my socials in the descriptions, and take care. Goodbye.